I want to do a video here how to get internet in the mountains, and this is a map of where all the cell towers are. So first thing I did was a survey map to see what towers are close. So that's about 5 miles to the closest tower, and currently if we bounce off that mountain, we get hit or miss, a little bit of cellular, pretty like not even usable. Occasionally a text message goes through. Here's the various towers. Obviously not going to go through this mountain. I'll have the link to the website in the description. The close tower, which is 5 miles, it could almost go through, but we still got 2 mountains that we're having to hit. And here's the other towers, just not going to happen. Definitely not going to happen. Radio does not go through mountains. It actually even has a hard time going through trees, especially when the trees are wet. So first I looked at all the towers. Nothing is coming close. And the one tower that is close, you can get hit or miss, and unless you climb up the mountain. And that's what this video is about, is that we're going to run internet about 1,500 feet up through a mountain. I'm going to show how to do that. Turns out climbing the mountain next to, which is still part of the same property, going at about 60 feet up, you start to get cellular. And then when you go to the top, which is about 200 feet up, you can see we got a super clean signal. Now we just have some trees to go through. The trees are so thick you can't even run solar. It's just not going to happen. You'd have to cut down a bunch of trees to get even a solar cell to work. But what we're going to do is, the house is located down in the bottom there, and we're going to run a cable up to where the internet's good, and then put the hotspot up in a tree with an antenna. So this video is going to show start to finish all the parts, all the setup, all the soldering, running the cable, the complete job of running internet through a wire. Now your regular Cat 6, you can only go 300 feet. We need to go about 1,500 feet. So there's an adapter which you can go Cat 6 to Coax, and when you go Coax you can actually go miles on the Coax. So you have a transmit which runs 56 volts through the Coax, and then it has a receive right here, and the receive is going to give 56. It's going to have a voltage drop, and it's going to power the hotspot, which will be up in the tree. And then to make it also work better in the rain, the hotspot's going to have a multi-band high gain antenna on a tree too, and that'll give really good reception. Found this surplus wire on eBay. It's underground wire, and what we're going to do is lay it on the mountain and tie it down to roots using stainless steel clamps. This wire also has a gel, and it has triple insulation, and it has a steel core on it. If you want to test the cable, you can pull it out of the hole, and then I trimmed it down with the razor so it doesn't cut into the cable. And then this whole end spins, and then you spin the other end, and so you kind of pull it quickly, and the cable will feed, millimeter by millimeter, and then you can get enough out of clean cable, because it might be kinked when they pushed it in there. You get it out clean, you can cut it, put a connector on, and then you can do all your testing not on the mountain. It's a lot easier to test it in your house. It's RG11 cable, and right now I'm going to show connecting a connector to it. We're going to use N-style connectors, And those will get also wrapped in silicone fusing tape so it can handle moisture. So I'm going to strip it back. I don't really care how far I'm stripping it back. You just lightly score it, and you're not cutting all the way through, just halfway through, and then it'll just peel off. And I start it with a small screwdriver, and I just peel it off right where I scored it, just like so. Now I'm just going to push the braids back, and then the collar is going to go over the aluminum, and it's going to slide under the braids, and then the rubber is going to be squeezing the braids, and I'm also going to cut them a little longer so that they can also squeeze on the front. Now the braids are too long, so I'm going to cut them flush with the outside of the ring, and then strip back in the middle. Now you can see in the connector it's flush. The Teflon is flush with the front of this. So I'm going to use the razor and I'm going to strip back flush all the way around, or just slightly give it a little bit of space there because it's going to push it under the cable. And don't slice, just push, because you're only cutting through literally styrofoam. Now here's where I'm going to trim my inner core and then solder it, but don't forget you have to have, there's a Teflon washer on each side, so we have to have Teflon there. But I'm going to trim that back, get my connector where it's supposed to be. And this is an odd cable, this is why it's only 20 cents a foot. I do have to fill that in with solder there. Clean your iron, a little bit of water. I'm set at 400 degrees Celsius, which is pretty hot. Gonna fill the receptacle with solder. Not a huge amount. Pre-tin. Big old solder ball on there. Now since this is female, I'm just holding it with a pin. And I'm gonna heat them up at the same time. Slide it together. Just like so. Now I'm going to clean the grease with a little bit of alcohol, so that way the rubber can grab that outer coating. Then we got our other side. Teflon, just like so. Slide down. This is going to actually compress, going to make a good connection, and it's also going to press it forward. And then we just screw it all together. If you're not centered, it'll center because it's just styrofoam holding the middle. So that's the female connector, and then I ohm it out. I get 11 ohms on the 1,000 feet on the inside, and I get 6 ohms on the outside, and of course no shorts to ground. So now I'll show how to do the male connector at the other end. So here's the order. You have our nut, our skinny washer, and then the rubber. So we need to slide these 3 on the cable first. Now I'm going to score it about 1 inch back. It's not important. And then do an open there, and then take the insulation off. Now what I like to do is get the smaller washer on, and I'm going to sandwich in between these two. It'll get a better connection. So I'm sandwiched between. Now I'm going to use the pliers and just jam that one in. And you can see I got a pretty good sandwich there. So now I'm going to trim off all my extra and strip my center with the razor, not cutting, just pushing. Now these connectors are designed for LM400, so it's a little loose. LM400 has the bigger core, but we're talking way more expensive. I'm going to do the same thing. I'm going to fill up with solder and pre-tin and just push them together. Made a little holder since this is male, so I'm going to fill up, not all the way with solder, but put a decent amount of solder and tin right there. Iron is set at 400 degrees C. Let's clean the tip off on some wet paper towels. Decent amount of solder. Get some more right on there. And then now I'll just put them together. Get it nice and hot. Squeeze it together. Hold it. Easy peasy. Be careful not to put too much solder or you'll create a short. So I'm cleaning the solder out of this connector. Now I want to degrease, get my grease off so that I get a better grip with the rubber. And then ohm it out. And then if you're wondering if the middle is in enough, just check it to another connector and it's good. Here's the internet speed test without the 1,000 feet cable, just direct connection. So we got 50 and 9. And now let's redo the test with 1,000 feet of cable. So I'm using this LinoVision PoE to coax running through the 1,000 feet. And it's kind of disappointing on the data rate because the mountain I'm doing 1,500 feet. And I'm only 10 megabits. So I'm going to try some different adapters, which is great for people watching this video because you don't have to try it yourself. I'm trying it for you. Now I sent back those cheap adapters and switched to, this was open box, so I saved some money, but Planet Networking adapters. And they're spread spectrum of 2 megahertz to 20 megahertz. And now my speed, I'm not bottlenecked anymore in the cable. That 74 is probably the modem itself, the cellular. And I'm running through 1,000 feet right now. I'm going to go ahead and test it through 2,000 feet. So now let's get the enclosure modified. So I had to drill 1-inch holes. I'm going to run my coax and then my antenna, and this will just be a spare. And it's important on any outdoor enclosure, you have to have a drain on the bottom because they're never going to be 100% watertight. And just going to drill a couple holes. This is the low side, if you look at it, as a drain. And it's pretty small, 1/8 inch, where bugs aren't going to get in. These antenna cables, they don't have locks, so I'm taping them in to hold them in position. Now we're on nice steady green. Let's do some speed tests on 2,000 feet of wire. So I'm going to show a baseline for the 2,000 feet of coax through my cable at home. And make sure you plug to the data output that's not 56 volts, because we got 56 volts here and your home router might not like it. So we're testing just what is our speed limit on this cable itself, because I can get 200 megabits per second on my home network, and we got 86. So we're limited to 86 on the 2,000 feet of coax, and the uploads are always throttled. But if you look, it's nice and steady. The download is just a super steady line. And that's just because it's being throttled in the cable adapters itself. So this is the entire bench test setup. 2,000 feet of wire. This is an isolator for lightning. It'll be in the cabin. This will be in the cabin here. 56 volt Ethernet to coax converter. And this is a power injector for a Wi-Fi router that'll sit on top of the cabin. And then this goes up in the tree. Our enclosure, which is just, you can barely tell it's warm. And then directional antenna, that'll be up there. And right now we're streaming 4K video. And this is the hardest video to compress, just freestyle drone footage. 4K, no lag, no nothing. And here's the internet speed test. So we got 83 download, we got 42 upload. I'm checking the Wi-Fi speed now on the mountain Wi-Fi, and I'm going all the way to my townhouse there, across the parking lot, and got a pretty decent speed. So here I'm going to go through the complete setup of the hotspot, which is a Netgear M6, which sits on top of the mountain, and a router, which sits in the cabin. And it took me a couple days to get these settings right. So this little 5 minutes of video can save you a lot of time. So let's go to the hotspot first. So basically, I'm connecting with an Ethernet cable to a laptop, and then it's going to go to the address, this address here with index, and then it'll be an admin login, and then the default admin password. And then right here, I just go down the settings. The internet's going to be cellular only. There's not going to be getting internet from anywhere else because it's out in the middle of nowhere. And then I'm turning off the Wi-Fi because I want to conserve power. I want to keep the heat down in the box, which is already gets enough heat there, about 5 watts worth of heat. And there's nobody up on the mountain anyway, and the Wi-Fi doesn't go through trees very well. So the Wi-Fi is turned off. Power mode for this AT&T hotspot, or it's a Netgear hotspot, when it's plugged in, it does the best performance. And what was really important is that you don't have to go up to the mountain and press the power button. And when it's plugged in, just cycling the power will restart the hotspot. So we're going to select plugged in. And then on our mobile router setup, so it has its IP address there. Zoom in a little bit. And everything auto. I'm pretty much circling the stuff that's not auto. So we're doing IP pass through, and it's acting like a cable modem, but the cable is going to cellular. And then it runs the DHCP server, which will assign IP addresses to anything connecting to the local network. So it starts with address 20, and then it'll fill all the way up to 99. So you could have 79 devices on the network. And if you wanted more devices, just change that number there. You can put thousands of devices if you want. And then it doesn't really use tethering, but I just put charge only anyway. And then you have to enable the Ethernet port, which it does default enable. But if you can't get it to work, it's that setting right there. And then the Ethernet speed, that doesn't seem to matter. Just leave it at the default, the 1000. It's only doing, yeah, it can only do like 90 through that coax converter anyway. And then you can get an alert, set your plan limit, and then at 80% send an alert. And then here you want to turn on roaming because some towers will be roaming and they don't charge. There's no extra fee on it, but you want to have roaming to be able to connect to it as if it's connecting to another brand tower. And then I just enable GPS. There's a lot of websites and stuff want to know GPS. This took me 6 hours of headache figuring out this VPN pass through. If that's checked, it'll interfere with the encryption that takes place over the coax to Ethernet converters. And the internet goes from awesome to like really horrible internet with packets, really a lot of bad packets. So you want to make sure you're not using, don't check that. And this is default. And there's other stuff right there. And then you save it, and then the hotspot does seem to hang after you save it. You have to cycle the power, which isn't a big deal because you can cycle the power at the cabin. You don't have to go up the mountain to change settings. And that's it for what's on top of the mountain. Let's go to this is a router that's at the cabin, and I'm using an outdoor router. That way I can get further range around the cabin. It's going to be set up as an access point. But to first access it for first time setup, you have to connect it with a wire to your laptop. So you have to go to your settings, and then you're going to right click on your network adapter, and then you're going to click on Internet Protocol version 4, which is right there. And then you're going to click properties, and you got to set a fixed address for your computer because you're just connecting not to the internet, but you're going to connect directly to that access point with the wire. So you click there, put that in, click OK, and then power on the router, and then this will be the default address that the router is going to use for first time. Then it's going to prompt to ask you to put a new password in. Well, it asks for the old password first, which is admin. Then you can put a new password. Your new user is still going to be admin, and then just choose a password that you want. And then you're going to keep the default for your address setting on the access point. You're going to keep the default where the DHCP server, which is going to be in the tree in the modem there, that's going to assign the IP address. And then click on wireless. That's where you're going to put in the name of your Wi-Fi. Make sure you got both bands selected. Then click save at the bottom. Then you're going to click edit to set your password. And then we don't need this setup Wi-Fi that lasts 15 minutes. So after you click on edit, it gives you a screen where you're going to set your security, WPA2 3/personal, and then you're going to set your password right there, and then always click save at the bottom, and then you can set your time. So we're going to use a time server. That address is a good time server. Set your time zone, daylight savings time. Just copy that over. And then Wi-Fi scheduler. You can have an auto reboot once a week at 3 a.m. And then that can help for health. And then you're going to click save, make sure you click save on everything. And then it's going to have a thing that says apply. And so you're going to apply all your settings. And then it takes a few minutes. The router will reboot. Then after you're done with the router, you want to set your network adapter back. So in your network and your setup, network connections, and then you right click on your network adapter, and then click here on the protocol version 4, and then check back. It's going to be an automatic address. And then for firmware updates, because you need internet for firmware,
Yeah, so you're going to download the latest firmware from the website there, and then you're going to log into where your router is. And if it's not located, it's probably not going to be at that address. Use the address from locator.exe, which is right down here. You download locator.exe, and then it'll look for all the ingenious products on your network. So in that address, you would use the 192.168.1-26. You type that in, and then you go to the firmware section, and then you put in that file that you just downloaded, and then click upload, and then that'll give you the latest version firmware on your router slash access point.
I want to show a good application here for finding the best place on the mountain to place the hotspot to get the best signal. It's called Google Earth, and you can make a project, which I've saved it local as a KML. It's called Mountain Wi-Fi, and I can save points on the map. But what's really neat about it is you can do a three-dimensional. It's a topology map that's accurate to actually within a foot, so you can actually see the clearances. So you get your cell tower coordinates, which is up here, and I set it to actual base of the tower. You know, you can write in the actual feet of the tower there. And then you can set up waypoints where here's the cabin and the property line that I drew, just adding a line. And so here's right where signal can barely, where you start losing it when you climb the mountain. And this is 64 feet higher than the cabin itself. And if I hit fly 2, it'll put me on that spot. And notice I don't see the tower. The tower is just over the hill there. And so that's too low of elevation to see the tower. Well, let's check out some other spots. And I get a good signal here, but it's not on the property line. But if I fly to that, now you can see the tower is clearly visible. It's 5 miles away. But when you're on the mountain, you can't see anything with the trees. So this Google Earth is really nice. So let me show you how I add points into that. Let's go back to 2D. And so I'm going to end up where the untitled placement in between the 251 feet elevation higher or the 185. And so let me show you on these points. To get the camera view, hit edit, more settings. So this longitude and latitude, that's the map location of that point. The altitude is generated by Google. It knows the altitude, and that's above sea level. Now here's the thing, this camera view. So you want to copy over the GPS, copy those, just cut and paste. And you want to have your heading, that's your compass heading, which I've found is 349. And then the tilt is the actual angle of the camera, so it's 90 degrees. And then the altitude, and this is where your camera view is, you want to match it to your actual point. So 673 meters. Don't use the capture this view because that just populates it with where your camera currently is. But you want your camera to be exactly at the ground level and pointed towards the tower. And so on that one, I got my points right here. Like on the best spot at higher up the mountain, I just click fly to, and you can see I got a nice clear view. Now, when I'm at the cabin, you go down here to the cabin, I get no cell service at all. And if I click fly to, it's like, yeah, I have a giant piece of rock blocking my view. And actually, if I was going to build a tower at the cabin, this is really cool. it could tell you how tall your tower has to be. So I'm going to click cabin, I'm going to edit, and on my camera view, rather than matching the 596, let's add 30 meters to that. So let's make that 626. Click done, click back, fly to. So if I had a tower, I'm still not high enough to see. So let's edit that again. Let's go a little higher. Let's go 10 meters taller. 36, done, back. And there I could barely see the tower, but now I got to clear 50 feet of trees. And so just using Google Earth, I could see how tall I have to build the tower. It ends up I need 150 feet tower, which is doable, but not on that property because that's just, you have to have guy wires, and there's really no room to do a 150-foot tower. But turns out just climbing the mountain, I can go 250 feet up, and actually the distance on that, you can measure the distance with the zigzag pattern, and I'm about 1,500 feet to go up to where, you know, the good spots are on the property line. So Google Earth is a cool app, and it's all done on the cell phone here. Next up, time to deploy up the mountain. Let's go find a good tree. Lucky me, I have a hunting trail that goes up the mountain, but it does double as a bear trail. So now with the binoculars, I got a clear shot of the tower 5 miles away, and property line is here. So I'm gonna get a little closer to the cabin, but still stay above the trees on the other mountains. Now I did a quick speed check here on the cart where I'm aiming at the tower, and I'm running the 56 volt power supply and feeding through to the converter and just hooking up to Ethernet port, and I get really good speed, like 59 megabit download, 21 upload. And which is really good is I'm on the B2 band, which is the 1.9 gigahertz. So that gives you your high speed data versus the 700. Because at this altitude, I'm only cutting through 3 trees and then 5 miles of air. Now it is important that you use the tower for your cell service, because Verizon doesn't use that tower and it gets a pretty bad signal up here. But AT&T works really well. All right, I'm on the selected tree. You want to make sure you tie off your ladder, and just testing the internet speed just locally, and we got a really good signal. We're on the B2 band, high frequency band, and our internet speed 59 meg, 25 meg, so it looks good. I'm using this cloth camo tape. Look how well it hides that wire. Disappears. And I have a ground for the lightning rod, and I'm putting the lightning arrestor. You're gonna have 2 arresters and grounding in 3 different places. When you run the cable, you wanna leave slack all the way down. Like I'm gonna secure the tree, secure there, and throw leaves over it, and do a long path all the way down. Now the cable naturally tries to get tight because gravity's taking it down the mountain, so you want to pull up slack and then do zigzag pattern and have it where if it pulls, it's going to break the clamp rather than kink the cable. So here's the outdoor router for the cabin, and it's up at a high point so we can get some Wi-Fi coverage all around the area, and I found an easy way to run into the attic. And then here we're just going to disguise it as a pipe. Just open that up and stick that right over the router. Now grounding is super important on a 1,500 foot antenna. And being on a mountain, you can't ram an 8-foot ground rod in. So what you do is go by a tree, because the trees actually finds the cracks in the granite. And then you bang in as far as you can, cut it, bang another one, cut the rest of it. So we got 8 feet of ground rod, but it's in parallel, and we want to tie these together. So we're going to solder them with a torch. And first we wrap it, and then squeeze it together, like so. And then they're all soldered together with silver bearing solder. It'll be in the parts list, and use a torch on it with flux. So here's our midpoint connection at 1,000 feet. So I'm gonna close that and put 2 clamps on there. So now I'm clamped with ground on both sides of the connector. Touching up a little more solder on there. You don't want to use too much heat because this is steel. The rod is made out of steel, as you can see there, and it just has copper cladding. But this will be a connection that can get buried. And you have to use the flux too. Sealing connectors against water is super important. Now these are end connectors which already have gaskets in them, and then their compression with the rubber. But I'm going to make another barrier around them using this silicone fusing tape. But first I'm going to wrap it with electrical tape to kind of compress it down here. Now this self-fusing tape, it works by being stretched. So I'm going to make a gasket around my copper. And you're stretching it just about to where it breaks, and it actually welds. Now that I have my ends, I'm going to use the wide and just make it into a big ball. Now on that joint, it has thousands of pounds of compression because every turn adds up, and it's hard as a rock. And you see it's squeezed in where my copper is, but you want to have your copper, have that on the downside anyway. So if any water gets in, it'll want to come out that way. But we got a good connection. Now we're at the cabin. So the ground wire goes to the router, soldered connection there, and it goes down to the converter. Let's hook that up and let's see if everything works like it's supposed to. And it turns out this power supply, which is 56 volt, that puts it into power over Ethernet, is not compatible because it drops down to 24 volt if it's not happy, and it was definitely not happy on the mountain. It would work half the time. So we left internet on for a week, but it was shutting down. And so we're now just go with a standard 56 volt power supply. And it'll be, all the parts will be in the parts description. It's much more reliable because you want both lights to be on right away. Yeah, the system won't run on 24. It has to be 48 or 56. Here's a 6-month update, and it works really good. We still got full speed. Some diagnostics you can do. You know, you'll see your data light. You'll see your link light on the back working. You can test your power supply. Check your voltage there. Make sure that's good. I did have to do a setup change on the router on the roof, and I made it go to its auto address rather than a fixed address. So the beauty of watching this video is you learn everything in one video and you don't have to experiment. And I have the full setup documentation in the video. And I did also add, what we have here is a watchdog. It's pinging the internet, and the Wi-Fi goes down. It'll restart every 10 minutes up to 5 times to if there's anything that, you know, restarting your Wi-Fi fixes it. So it's nice, you don't have to be out here to have a restart. But everything's still working good. 6 months later, inspected the cable, nothing was eating it. Plenty of slack on the mountain. So inside the box, 6 months later, through the winter, you see it's dry as a bone. Everything still looks good. There's plenty of slack. We checked the cable all the way up the mountain, and no trees falling on the cable. All the tie downs still have slack, even though we had a bunch of snow and ice on the mountain. And this project turned out really well. Hope you like watching the video. Thanks for watching.